Hi everyone. This is a video for Math 180, and what I'm planning to do is a few of the problems in the back of the section for section 13.5. That's the section on volume. And I just want to work through number 3, and these are all from assessment A. Number 3, number 4, A and B, and then number 10. Okay, so let's take a look at number 3. The Great Pyramid of, I think it's Cheops, has a square base of 771 feet on a side and a height of 486 feet. Okay, and then it asks how many rooms of this size, 35 by 20 by 8 cubic feet, would be needed to have an equivalent volume. So let's first find the volume of the pyramid. So I'm going to draw a little picture. It's a square base. So this is 771 foot by 771 foot. And its height, this is obviously not to scale, but let's say its height here, H is 486 feet. Okay, well, the formula for a pyramid is 1/3 the volume of the corresponding prism. So 1/3 of 771 feet times 771 feet, right? That's the area of the base. And then times the height, which is 486 feet. Okay, so this, I put this in my calculator, and you get 96,299,442. And notice it's feet, it's cubic feet. Okay, so that's the volume of the pyramid. Now, each of these rooms is, so this is pyramid volume. Each of the rooms have volume, well, it's a 35 foot times 20 foot times 8 foot, which is, if you multiply those together, you get 5,600 feet. Well, 6,300 cubic feet. So this is room volume. So how many rooms will it take? You need to divide this by this. So 96,299,442 cubic feet over 5,600 cubic feet. So writing it this way is nice because you see that the feet cancel and you'll just get a pure number. And this doesn't get you exact, but if you round up to the nearest room, it's 17,197 rooms. Okay, so it takes 17,197 rooms of this size to basically fill up the pyramid. Not too exciting of a problem, but it's the, kind of volume formula kind of problem. Okay, so a little bit more direct are these ones in number 4. I'm not doing every part in number 4, I just picked out these two. So find the volume of these two things. This one is a hemisphere and then on top of a cone. So let's do the pieces separately. The hemisphere, well, volume for a sphere is 4/3 pi r cubed, and we've got half of a sphere, right? Okay, so it's like that, and then we plug in, well, first I'll cancel this off, so I'll get 2/3 pi, and then I have to have 4 centimeters cubed. Okay, So notice that you'll get cubic centimeters, but you also get 4 cubed, which is 64. 64 times 2 is 128. So this is 128 over 3 times pi cubic centimeters. Okay, that's the hemisphere. Okay, we're going to have to add that to the volume of the cone. So if we do cone, well, the volume of a cone is 1/3 the volume of the corresponding cylinder. So it's 1/3 pi r squared h. This is a cylinder and it's 1/3 of the cylinder. So in our case, it's 1/3 pi. R is 4 centimeters. 4 centimeters squared, and this is 8 centimeters. So 4 times 4 is 16. 16 times 8 is actually also 128. So this is 128 over 3 pi cubic centimeters as well. So the total volume is 128 pi over 3 plus another 128 pi over 3. That's 256 pi over 3 cubic centimeters. And if you make that a mixed number, it'll be 85 1/3 times pi centimeters cubed. Okay, well, this one's actually easier. This one's a prism. So remember, volume of a prism is area of the base times the height. So the volume is going to be area of the base. So that's 1/2 times 6 centimeters times the height, which is 6 centimeters. So that's area of the base times the height, 12 centimeters. So let's see, we've got 1/2 times 6 is 3, 3 times 6 is 18, 18 times 12. 18 times 12 is 256. I'm sorry, 216. So this is 216, and notice it's centimeters, 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 cubic centimeters. Okay, so that's number 4, parts A and B. And let's do one more. It's this one here, number 10. So the Earth's diameter is approximately 4 times the moon's. And assume both are spheres. What is the ratio of their volumes? Okay, so the volume for a sphere, again, is 4/3 pi r cubed. Okay, so let's say the moon's is, use m. So the volume of the moon would be 4/3 pi m cubed, whatever the radius of the moon is. Okay, so if the Earth's diameter is 4 times as much, well, that means its radius is 4 times as much. So the volume for the Earth would be 4/3 pi times 4m quantity cubed. Right, so this is the radius for the moon, then 4 times it will be the radius for the Earth. Okay, so notice you got the m cubed, but you also got the 4 cubed. So notice this is 4/3 pi times 64 m cubed. And let's move the 64 out front. So it's 64 times 4/3 pi m cubed. So notice when I find the ratio is going to be, well, it's 60 times as much, right? So the ratio of Earth, Moon is, 64 to 1. And that kind of makes sense because this is based on a cube. So if you multiply the radius by 4, you're going to multiply the volume by 4 cubed, which is 64. Okay, so that's a couple of problems from Assessment A in the back of 13.5, section on volume.